Hello everyone. So today we're going to talk about optical biometers around the world. This presentation is going to be in English. I hope this doesn't cause any problem to anybody. So optical biometers are very essential tools in modern ophthalmology practice. It's very essential for tracking myopia or also for calculating IOL for cataract surgery. In this presentation, we're going to talk about the devices available on the market, essentially optical devices and not the ultrasound ones. So, as you all know, the parameters necessary for optical biometry are axial length, anterior chamber depth, keratometry, central corneal thickness, lens thickness, and the white to white, as well as pupil size. So in biometry, we either have ultrasound biometers or optical biometers. The ultrasound biometers comes either with immersion, so no contact biometry, or the contact biometry, which is the A-scan. While the optical biometers uses multiple technologies, so each device uses a technology that we're going to see in a second, or some devices are hybrid, so they use multiple technologies in one device. The key difference between ultrasound biometry and the optical biometry is in these features. So in the axial length, for example, ultrasound biometry axial length is an anatomical one. However, in the optical biometry, it relies on light reflection. For the method, ultrasound relies on contact. So there's always a risk of compression errors, and there's also a risk of infection. And both are not really there with optical biometry because there is no contact. For keratometry, ultrasound biometry we always need to utilize another device to do the keratometry measurement. However, most or all optical biometers comes with keratometry measurement integrated in the device. For the operator dependency, it's very high for ultrasound, so it gives us variable results. However, in the optical biometry, most devices are automated, so the dependency on the operator is very low. The optical biometry market is in constant evolution since early 2000s, and that with the creation of the very first ultrasound biometer, which was the IOL Master 500. In 2023, the market was estimated at $300 million. Experts believe that this number will likely double by 2033. So let's talk about the most available devices on the market, starting with IOL Master 500, which was the very first device. It was introduced in 1999. It uses interferometry as a technology. It measures axial length as well as anterior chamber depth. It's very reliable for everyday routine pre-cataract surgery measurements, for IOL calculations. However, it's very limited for complex cases like post-LASIK eyes. Second, we have the Lenstar LS900. It's an optical low coherence reflectometry device. It comes with variable measurements, with a lot of measurements that we've seen together. It does do IOL calculations. It's very accurate and supports multiple formulas. However, it's a bit slower compared to other devices. Next, we have the AL scan from Nidec. It's a reflectometry device, but it also has a Scheimpflug imaging. So it's a hybrid device that uses two of the technologies. It does do IOL calculations, notably keratometry and axial length, so it's very accurate in these two measurements, but it's less suitable for denser cataracts. Next, we have the IOL Master 700, one of the most known devices on the market. It was actually the first one that uses the sweat source OCD technology. This technology is known to penetrate well denser cataracts, and it also gives us a very good imaging system. We can see the whole ocular structure, including the interior chamber, the fovea, and the cornea. So it's very reliable for IOL calculations, but it's a bit expensive compared to other devices. Aladdin from Topcon. This one uses interferometry, but it also has a Placido device. So this one is a topograph, but it's also a biometer that does IOL calculations. It combines two of biometry with topography, but it's a bit known as a topograph compared to being known as a biometer. Argos from Movo, another device that uses sweat source OCD technology. It's very good for calculating IOL formulas, but it's less known compared to others. It handles complex cases as well as like the Biometers 700, like post-LASIK eyes, and it does a wide range of calculations of different formulas. Pentacam LXL wave. So it's a biometer coupled with the Shenflu camera. So Pentacam is essentially known as a topograph. It's very good for keratoconus diagnosis or for corneal diseases. It's very excellent in this. However, it's less known as being a calculator for IOLs, but it's a very good biometer. Galilei G6, well, this one is actually a topograph. So it's a topography device that has a rotating Shenflu camera with a Placido disc, but it also comes with reflectometry. So it measures different parameters like axial length, anterior chamber depth, keratometry, but it does not do any IOL calculations. So compared to others, you might need it for axial length tracking, but not for calculations. Next, we have the Nia device. Like the previous one, this one doesn't do either any calculations for IOL, but it's very good for tracking axial length, especially in cases of myopia. So we use it especially on kids with developing myopia. And we can also use it in surface ocular diseases because it has mammography and it also has a topography system mapping. And finally, we have two examples of the OCDs that are also biometries. We have the Revo NS30 from Optical, and we're going to see the second one. So both are all-in-one OCDs. They have imaging of posterior and anterior chambers. They're also topographs and biometers. So they can do calculations, but they are slightly less reliable in calculations compared to other devices. Same with the Huvits, so like the Revo. But this one is, the advantage of this one is that it's really affordable compared to other devices. So it's an all-in-one device. You can use it either for OCD, topography, and for calculations. Let's recap everything in this table. So starting with the Biometers 500, it's very accurate in everyday cataract surgery planning. However, it's less suitable for denser cataracts and complex cases. Well, for the Biometers 700, since it uses sweat source OCD, it's very good for complex cases like dense cataracts, post-LASIK eyes, and even silicone oil failed eyes. However, it's a bit expensive and it needs daily calibration. The Lenstar LS900, it has very good measurements for axial length. However, it's less effective in denser cataract. Argos also uses sweat source OCD, very good in penetrating denser cataracts, but it needs it's a newer technology and it's not very available. Pendacam AXL wave, Schönflug imaging with interferometry. So it's very exceptional for corneal topography and corneal diseases diagnosis. But it's primarily used for that, for corneal imaging and not for IOL calculations. Aladdin combines essential parameters. It's very affordable. However, it has limited precision in IOL calculations. Same goes for AL scan. Galilei, we said that it's primarily a topograph, but it can also do a axial length tracking. So you can use it for that, but it doesn't do any IOL calculations. Same for the MIA, no IOL calculations, but it's good for axial length tracking. However, we should know that what we notice in the MIA device, it's a bit difficult to track axial length that it's greater than 30 millimeter. For cases that are complex, like advanced keratoconus. And finally, we have OCDs that comes with biometry. So both examples that we've seen are spectral domain OCDs. They're very good for imaging. They show the whole structure of the eye. However, they're less accurate in IOL calculation compared to other devices. Okay, there is a small case, a small comparative case. We've done it on 3 devices available in Ibn Haytham Center in Algiers. IOL Master 700, Revo NX30, 130, the OCD, and the MINA device. So the axial length measurement was done on a healthy eye, no cataract. We had similar results for both IOL Master 700 and the MIA, so no big of a difference. However, there's slightly a small difference in the Revo NX30. And we also done a IOL calculation, so MIA doesn't do any calculations, but we had the same IOL result, the same IOL calculation result, using one formula, Holiday 1, and one lens, the same lens, which is Acreos. However, the post-operative estimation refraction was a bit different. So finally, if your recommendation, if you're interested in getting your own biometer, if you need it for cataract surgery planning and calculating IOL powers, devices that comes with swept source OCD or comes with reflectometry are very good in calculating cataract IOLs. Devices that has Schönflug-based systems are very good for refractive surgeries, and devices like the MIA, for example, are very good for axial length tracking if you see a lot of myopia kids with myopia. So your device selection should be based on your clinical needs, your budget, and the available expertise in your clinic. Thank you.